All right, everyone. Now officially starting, if you've just joined, again, my name is Nick Lotz. We're here to talk about building and hardening MCP, Model Context Protocol applications with Orkes. This webinar is scheduled to take place over the course of about an hour. In terms of what to expect, there'll be some slideware and concepts that we'll be presenting here at the beginning. I'll then drop into a demo to kind of take the concepts in practice. I'll share some resources as well for you as to take away and test on your own. Several of the things I'll be showing will have available GitHub repos that I'll be sure to share links to as well. So what's the motivation for being here today? Well, this is one of a series of coffee chats that we do here at Orkes. The goal is to just have kind of a casual way to talk about building things. Most of these talks have kind of a particular technical angle that we'll attack. But really here, the goal is to talk through some interesting workflows, almost always incorporating some feature of the Orkes platform. But really the goal here is for builders and developers like Maria and myself to talk to other builders and developers about what they can do and what cool things they can build. So again, the focus today is on MCP. And, this is a kind of a real pain point in the industry today. When the Model Context Protocol first came out, it posited to solve some really important problems around the abstraction layer of integrating AI tools, right? We were at the stage where AI tools, particularly LLMs, did not have a common set of schemas. There was not a standardized way that they can talk to both traditional applications and themselves. MCP was released as a protocol standard to largely address that problem. It's not perfect, but at the same time, it has provided, really useful abstraction layer. So the flow that we're going to take today is really trying to first kind of understand what is the MC protocol done well, and then what issues do we still need to solve with it? Like what are some very common pain points that we encounter? And then we're going to start introducing some tools. The goal of these tools is to provide us with a debugging and governance set of abstraction layers so that our MCP applications can be built, scaled, and hardened with as much standardization as possible. So as part of this flow, I'm going to talk through some concepts. I'll then drop into a demo, really looking at a couple key tools that we've developed here at Orkes. One is what we call the MCP Workbench, which is fairly new. It's a debugging platform that you can either host locally or experiment with on a web version. We also have Orkes MCP Gateway, which is a broader part of our Orkes Conductor platform, which allows you to expose workflows and tools over MCP to interact with other MCP servers and applications. Again, if you have questions that come in, again, feel free to use the chat portion of whatever platform you're tuning in on. And again, I'll be sure to build in some Q&A time at the end as well. All right. So I want to begin with this concept of the reliability gap. So MCP has become, again, an extremely valuable scheme for building AI applications that follow a particular standard. I would encourage you, if you hadn't, to look up the MCP kind of narrative and documentation. There's going to be a link to it in one of the tools I show in just a little while, but it's really become a very, in a lot of ways, a useful standard. It's not universally adopted though. And we've often found that a lot of teams, they're sometimes building tools and kind of tacking on, MCP without a full understanding of how to manage and debug MCP services and MCP servers. So when they're building this new abstraction layer and their tools fail due to timeouts, version mismatches, schema incompatibilities between requests and different tools, errors can be hard to simply find, let alone triage. And in addition, while MCP as a protocol like nominally follows a standard, the behavior can ultimately differ among different client and agent frameworks. And when when one type of schema is expected and you make a slight change upstream at a particular tool, that change can break existing agent prompts. So ideally, we want our AI clients or AI agents to communicate with whatever tools we have. But in reality, things like network timeouts, errors in schema validation, any lack of exception handling, new APIs like that can again result in breakage that we aren't fully able to troubleshoot, again, outside like troubleshooting tools. Consumer AI tools are pretty notorious for this today, right? Like if you use any type of commercial large language model, whether it's web-based, whether you're using like the API or SDK, you often find that like when something isn't working or there's a sudden network error, like you're given, a pretty basic error message that doesn't allow for a whole lot of troubleshooting. It's like, well, I guess something's down or not working, but again, it's hard to fully troubleshoot. So we want to change that. And one of the first tools that has this goal in mind is a tool that Orkes has released called MCP Workbench. MCP Workbench is intended to be a visual web-based debugger and test client for MCP servers. So you point it and connect the Workbench to an MCP server, and you then are able to expose the types of tools, prompts, tasks that the server supports, and then you can debug those within the Workbench. The Workbench is open source. There is a link here at the bottom to the GitHub repo. You can clone it, build it, and serve it locally. We also have a web-hosted version of it as well with a demo server on it, and also the capability to connect your own server. So part of the types of things that it allows us to inspect, which we'll look at here in just a couple moments, is ensuring that we can connect to our servers in the first place. Inspecting the raw JSON remote procedural call messages in real time. You can run tools and prompts and evaluate the responses, as well as evaluate any like workflow transformations you might have. We'll talk about that with regard to integration with what we call MCP Gateway in a little while. You can verify authentication. So we support API key headers, we support OAuth. And just in terms of the architecture of the Workbench, over here on the right side is just a brief, is just a flow chart of how the how it's built. And again, the idea here is it's exposed over a web UI. There's a standard IO bridge that is part of the architecture. And then it is interacting with whatever MCP servers you choose to connect to it. So again, you can choose to download and host it locally. What you can also do is you can choose to navigate to the hosted platform as well. And that's really the best place to get started. So if you're doing this for the first time, and if you even want to follow along with me here, my recommendation is navigate to mcp-workbench.ai. That takes you to a page that looks something like this. Let me actually get rid of this for the moment here. And kind of this is where you would normally start. This is currently in dark mode. If it's in light mode, it looks something like this. And notice there's a link to the underlying GitHub repo. If you are brand new to Model Context Protocol, I'm not going to the goal of this webinar is not to start from the very beginning of like, what is MCP? But there are some resources we link here. There's a fantastic talk that one of our colleagues, Austin, did on the Conductor MCP server, which goes into a lot of kind of MCP background as well. You can, again, introduce yourself to the protocol, kind of get started. Again, this is a good way to start. But if you're just starting with the debugging side of things, or you want to connect your own MCP server, again, couple ways that you can get going. If I share the Workbench server here, I'm now at mcp-workbench.ai. And I can choose, if I want, to connect a demo server that just is built into the Workbench project. It's also, if you choose to build it locally, you'll see this as well. And if I click connect, I'll start to see some output here. And then we can see that there's a couple of exposed mock tools that I can choose to select. For example, a basic, say, get weather tool. What I can do is I might say, hey, maybe I'm currently based in Nashville, Tennessee, or maybe Fahrenheit, run the tool, and then you can get you can validate the schema response that you would expect from the server. For some reason, I think I might have minimized the logs at the bottom. Let's see if I refresh this page. There we go. Yeah, let me reconnect. Perhaps most important is you can see the full validated connection logs here. And again, this is just the demo server. I'll connect to something more real here in just a little bit, but you can see the JSON payload. If I, again, connect a tool, like I did before, again, you can see whether or not it's an expected response. So in addition to just connecting tools, you can also see, by the way, the curl to the endpoint as well. Again, this is just the internal mock server. I'll do a real one here in just a minute. There's also a selection of different prompts that you can set also. So for example, if I maybe want to prompt an LLM that I've integrated for doing some type of code review, I might say, review this PR for feature branch. I'm just making something up here. And then again, you get a message here at the bottom in terms of validating the response, and you can also get the result. Again, this is just a mock server, but you can also validate that the schema is what you expect. Now, again, I haven't done the hard work of actually connecting a new server yet, but this is really just starting to kind of look around at what does this Workbench offer from a troubleshooting standpoint. All right. So more on this in just a little bit. Again, I'll add as well that I'll add a new server here in a minute, but just if I edit the existing server, again, this is just using the internal mock environment, but I can add authentication as well, which I'll do in just a little bit when I add my own server. And that allows to kind of validate both the connection, authentication, and the way it responds. All right. So a typical way that MCP Workbench might fit into your flow is it allows you to do a connect, inspect, validate, and reproduce loop. So as you're connecting your MCP applications with or your MCP servers with other tools, you can validate whether those tools are behaving as expected when they're being called. You can modify the types of headers that are being sent for HTTP requests, and it just gives you a good browser-based view to do so. So one example of this is just the simple baseline. Like, can you connect to your server and any available tools? Can you call a trivial one, like I showed a moment ago, and validate that the schema is what you expect? You can also connect multiple servers as well. So if you actually look at the MCP Workbench UI here, you can add additional connections and test those all within the same UI. And then you can also capture the full exchange, like I showed a moment ago. So you can capture tool call inputs exactly as sent, make sure they are not transformed in a way that's unexpected. You can see any structured errors. that might be thrown. You can capture the tool responses and any errors that go with them. You can compare expected versus actual fields and their responses. And you can also spot any client-specific differences as in naming and casing and string concatenation and format. Again, the goal being here in a large part is can be simple schema validation, but it can also be, are these tools returning any outputs in a format that can actually be fielded potentially by another tool in terms of what it expects. And then this becomes some place where you can do some continuous validation. So as you're validating inputs against the published schema, you can replay the same requests to potentially isolate server versus client issues. You can reduce the request. So like you can, trim any optional fields when testing a tool and reduce it to the minimal failing payload. And also have just like a general test schema where you can have sort of a set of canonical or golden requests that you can use to test any regressions. Okay, so again, MCP Workbench is meant to be a debugging layer for this. What we're going to do now is I'm going to start integrating and introducing another feature that Orkes calls MCP Gateway. And MCP Gateway is a layer in the Orkes Conductor platform that allows us to expose any tools, to expose our tools as MCP services. So that can be integrated with any clients or agents that know how to talk MCP, and they can also be debugged with the MCP Workbench. So that's what we're going to focus on here. So we're going to shift the discussion a bit more towards the workflow side of things. And if you've used Orkes Conductor before, there'll be a lot of familiarity here. If you're new to Conductor, it's a workflow engine that is used for really any type of arbitrary like software workflow that you might want to create. Whether it's infrastructure management, whether it's AI agent integration, whether it's business logic. And the benefit of MCP Gateway is that you can expose those workflows as MCP services for any types of AI integration that are compatible with it. And that's what MCP Gateway is. It exposes Conductor workflows as MCP tools. And when I use the term tool, I'm really referring to a route or a path that is expected. So each route maps to a particular Conductor workflow that the gateway invokes. Now, the benefit is MCP Gateway kind of provides a centralized way to manage not only your workflows, but also access control to those workflows. So authentication is configured at like the Orkes management level. You can reuse it across services. You can control and rotate tokens and API keys. You can manage what types of inputs and API requests are supported. And then you have all of like the auditability and visibility that you have because everything is centralized within Orkes. So the flow will end up looking something like this. And again, I haven't pulled up the Orkes UI yet. I'll do so in just a moment. But ultimately, if you have MCP Workbench like over here as kind of a debugging layer, the centralization of your workflows and then the MCP exposure happens here within Orkes Cloud. So you'll have your Conductor API that interacts with your various workflows, any execution workers, any integrations. The workflows themselves are exposed as an MCP endpoint through MCP Gateway, and then can be interacted with any clients, but also can be debugged with the MCP Workbench that I showed earlier. All right, so I'm going to jump into the UI in a moment, and I think the best way to showcase this is through a demo. And I think that allows us to kind of like think in terms of workflow logic and use Orkes as a layer to manage this. So let's think of a workflow that is phishing response automation. So imagine that we have a SOC agent and the goal is to triage a reported phishing email and then trigger containment. So our goals are summarized here. So we want to publish an MCT tool backed by a workflow in Orkes, a Conductor workflow. And the goal is to create the case, enrich it with needed context, ultimately return useful information like a case ID and status. We also want to make sure that we can very easily troubleshoot bad requests, bad inputs, reproduce any failures. We also want to restrict which clients can invoke the tool. So we're going to add authentication settings so only clients with permission can invoke this workflow. And then finally, we'll validate calls in MCP Workbench. And that'll allow us to kind of monitor the service and any route, any metrics, any connection issues for possible latency and errors. So that's what I'm going to jump into now. I have a couple things set up. So I want to kind of introduce the resources I'm going to use. Number one is I have a locally hosted MCP Workbench. This is equivalent to the one we have hosted at mcpworkbench.ai. I've just built this as a local server. I'm literally running it out on localhost on a local VM on my laptop. I just followed the instructions to build it from the repo that is here. So I have my local workbench. What I've also done is I've created an account. Give me 1 second here. In Orkes Cloud. So I've created a free developer account. All the steps that I'm doing today are reproducible on a free account in Orkes Developer Edition. What I've also done, and I'll share this as a resource toward the end as well, is I've created give me 1 second here. A GitHub repo that should be public. Check me on it if it's not public. I can make it public easily. I think I made it public. That has a Jupyter notebook, so a Python notebook, that includes all the steps I'm going to go through. So feel free, anytime after this webinar to reproduce these steps. Again, I just made this available for folks to test what I'm doing here later. All right. So let me start by kind of showing you the architecture of what I've set up. So the easy part is, like I mentioned before, I've set up MCP Workbench right here. And what I've also done is I've created quite a few resources in Orkes Cloud to kind of mock out this phishing triage workflow. So when you create these in Orkes Cloud, the way to think of it is Orkes Cloud provides a whole host of abstractions for creating reusable workflows. So what I'm about to kind of walk through and show is, are things you would create on the front end, and it might seem like a little bit, oh man, I'm creating a whole lot of resources here, or a whole lot of entities within Orkes Cloud. But the idea is those become abstractions you can reuse later for other workflows and so on and so forth. So when you sign up for Orkes Developer Edition, what gets created is a default, what's called application, with execute permissions on any workflows you create. So you need to have at least one application. And then again, Orkes creates this one by default. And then this application can then be given, is then given a bunch of default permissions that allows it to interact with other services or with other entities within Orkes. What I did next is I created my core workflow. So I went to my workflow, I defined a new workflow, and my workflow is called phishing response. And this one's pretty simple. If I click into it, give it a second to load here, we can see there's a couple core steps. Really what the steps do is they undergo a transformation of data between a potential input of a phishing, of details of a phishing email, and then an output of a transformation bit of data that will generate things like a case ID, a URL to the ticket, a summary of the case, a severity level. So if I look at this triage case part of the workflow, I can see that the inputs include the priority, the sender, what the suspicious URL is, report ID, summary, and then the output at the end. We'll generate a case ID, a status of the ID, again, the severity. So a couple of these are repeated, a summary. And again, the idea here is performing a transformation. So any integration with any tools or AI agents could potentially act on them. So this first example, this is not using any direct agent integration at this point. It's currently just validating the schema transformation and any potential problems we might see that we can then debug with MCP Workbench. All right, so this is my workflow. Now, this workflow right now, like without any other kind of configuration, is not exposed as anything that can be integrated with any kind of model context protocol capability. That's where service and route definitions come in. So if I go down here under APIs, we can see that I've defined a service that I've creatively named MCP phishing demo, and I've associated a route with that service. If I click into the service definition, we'll notice that I've literally toggled on. If I click edit service, I'll do that here just to kind of show you what the configuration looks like. I've simply toggled on MCP enabled, and what that provides, when I click save here in a moment, it'll provide actually an endpoint that's auto-generated. Orkes Cloud gives it to us. That allows me to connect MCP tools to this service. And then I've connected the service to, I'll go to my route in a minute. It's ultimately connected to the workflow I created a moment ago. I'll point out the route here in a moment. So I've given it a name. I've given it a base path. I've also assigned an authentication configuration as well, which I've defined somewhere else that I'll go to in a moment. I've determined what connected endpoints are allowed to reach it. Here I'm being simple. It's literally just my local host MCP Workbench, but I could add particular allowed origins of tools or endpoints that are allowed to connect to the service, and then any allowed like headers that could be part of any requests that are made. If I look at my defined routes, click into that here. I have this route defined that I've given the path phishing -response. It accepts post methods to the workflow phishing response WF that I created earlier. So I have this kind of three-way mapping here between this route I created and the service that's exposed as an MCP endpoint and the workflow that I previously defined. And then lastly, as kind of you may have seen earlier, there is authentication. I've defined an authentication with an API key, which basically is requiring that I'm not allowing unauthenticated access to this service. You have to use an API key to authenticate to the service, or else it won't work. All right. So with these things in place, and the key element, again, being the service is now exposing an MCP endpoint, which I can find right here. Now, if I go to my Workbench, I can test my responses to this MCP service. So what I've done is I've added a new connection. So here I am at my locally hosted Workbench. I'm calling it phishing response. If I look at the details, I added the URL to the MCP endpoint, which was again generated by Orkes based off a concatenation of the service. And here's the endpoint. I do require API authentication, so I've added that here. And now if I click save, and I click connect, fingers crossed to the demo gods, we can see we're now starting to get some responses. And I think it's might be a little bit hard to read. Let me see if I can zoom in here. There we go. So here we're just seeing some basic responses that is indicating, yes. So here are the available tools and schemas that might look familiar from the workflow that I mentioned. And in terms of my available tools, based on what I wrote and what I configured, is I directly support as a tool a post request to the workflow that I created in Orkes earlier. So if I select this post request, notice I can add in the same parameters that I defined in my workflow definition. So I might do an example here, and then I can validate it here in Workbench, but I can also validate it on the Orkes side as well and see what the response is as shown there. So I might say summary is optional. I might leave that blank. Suspicious URL might be something like, give me a moment here. Evil.email. I'm just making something up. The sender might be Evil Corp or evil@evilcorp.com. Actually, I'll do this. The report ID, that's something I can supply. I'll just make it up. Subject. And then the reporter email might be, nick@mycompany.xyz. And then source, where the request originate. Maybe it was sent through a UI form. And then the priority, urgency level might be, we'll say hi. And then if I run the tool, we can see the structured response here at the bottom. And then we can also see a summary here. And notice that we have, again, the JSON schema of what is defined to be returned in my Orkes workflow. So I can also validate this on the Orkes side as well. If I hop back over to Conductor and I click into my workflow, I can see there was a workflow execution that just happened, like right now. If I click into the workflow ID, sorry, I forgot to share here for a second. Let me go back. Forgot to reshare this tab. So here I am back in Orkes. I see this execution that just happened. I can see the execution completed successfully. And then I can validate the inputs and outputs here as well. So if I look at my input, I can see both the details I supplied, as well as like the overall logic that's being used on it to transform it. I can see the result here from this first step in terms of triage, and we can see a status indicator. And then this last step of the workflow, I now see that there is a case ID assigned to it. I can see a summary. I can see the severity still. I see the status containment started. Right, this is the full task execution JSON as well that you can see within your workflow. All right. So I kind of validated it in two directions, right? So again, showing the MCP execution there. Let me go back here for a moment. We would validate it both in Workbench and in here. Okay. So what is next? Well, a good next step is, where MCP tends to be most often introduced is now starting to incorporate any type of AI agentic workflows. The benefit is that that can be pretty easily done here. Now, the example I did here was very much just a kind of a basic text or data transformation. But ultimately, like the layer in which you might then integrate is some type of, AI, integrated AI agent or prompt like input and output as well. So if you go to the Jupyter notebook that I created towards the bottom, first of all of these steps are basically all the same steps that I did here in building out the Orkes flow. There are some environment variables like your endpoint URL. Most of these are recommended here, but there's a couple things like API tokens that you'll need to set yourself. But if I scroll to the bottom, the exact same thing, the exact same validation would work with any type of agentic-based flow. So an agent might receive a user report. There'll be a JSON payload that matches the schema expected by the MCP tool. The workflow is exposed through MCP gateway and receives a result, and then the agent might use the result to respond to the user. But you can still review the execution in Orkes. If you're interested, there's a couple really good, let me pull this up here real quick. Give me one moment. There's a couple really good tutorials about using AI agents with Orkes. One of them is this one that allows you to, again, kind of use this type of native workflow capability that ties so well with any type of agentic integration. All right. But again, I don't want us to get ahead of the idea that ultimately we're working with an abstraction layer that allows for any arbitrary connection with tools, agents, business logic workflows, traditional software tools that you might write. And again, the idea here is you have any of your workflows created in Orkes exposed as MCP endpoints, and then can be validated pretty easily within the MCP workbench. All right. So with that being said, what I want to do now is I want to talk through kind of a couple next steps of where to go forward. So once again, this is something we'll be continually building off of. That's largely the world we live in today. MCP is increasingly important and being changed, and with new alternatives coming out all the time. Recommendation: play around with the MCP workbench. It's really easy to get started, especially with the demo server. There's a lot to learn by building it yourself. The instructions within the Workbench repo are quite good in that regard. Take a crack at the demo notebook from this webinar. It's a pretty straightforward demo. It does require an Orkes Developer Edition account, which you can sign up for free at developer.orkescloud.com. It gives you access to a default application that has, again, execute permissions on any workflows you might create. You can also create up to 3 of your own applications as well. And that allows you to kind of get started with this centralized management layer. All right. But that being said, I see a lot of these links were put in chat as well. Thank you for watching. What I want to do now is I want to field any questions that might have come up, if there's any additional Q&A. Otherwise, I might kick over a couple questions just to kind of, get the conversation going with Maria. Maybe if you're there, I might just kind of riff with you for a moment on a couple of things that you found in some of the own recent work you've done with LangChain. But are there any other questions that have come in? or any questions from anyone at all that I haven't yet answered. All right. Maria, how do you feel about jumping in for a moment? I know. Hey, Maria. So I know you've done some recent work with LangChain and agent integration there. Do you want to talk a little bit about some of the work you've done there and kind of lessons you've taken from it?
Right, yeah. So if you've attended our previous coffee chat, we did it on how to integrate your LangChain agents with Conductor. Um, and I mean, we have a pretty extensive blog post on the process behind that. Um, but I mean, overall, what I found is that it's pretty simple to not just build your own agent within Conductor, but you can also like bring any agent that you have and put it as a task in Conductor. So what Nick was showing you as one of the tasks, like Conductor workflows are built through tasks, and you can just have another task be its own AI agent.
Yeah. I think the last thing is, when you were working on this, were there any like real, when it came to like debugging or anything like that, were there any real like sticking points where, I guess, what was like the biggest pain point you encountered when kind of building these things out?
Not in terms of MCP, but so it would be like definitely something else, like unrelated to MCP. But in general, I found it super cool to be able to debug visually. And we also like saw some of that, through your live.
Oh, thanks. You think you broke up a little bit there. That's okay. Yeah, thanks for sharing all that, Maria. Yeah, and again, I think the lesson there is ultimately any kind of modern applications we write today. In a lot of ways, um, it very often is glue code that we focus a lot on between all these different services trying to interact with each other. And because AI agents in particular today, there's still a fairly immature uh, it's still a fairly immature industry, right? It has really only taken off within the past couple years. The tool and debugging layer is still very much in under active development. And just like in cloud and infrastructure services and any other types of software, there's been a whole ecosystem of tools created to catch up. That's what we're really looking at today with the tools that I described. All right. All right, folks. Well, again, I think that just about does everything that I was hoping to share here. Let me go one last time and reshare the, give me just a moment here. The next step slide. Again, highly encourage you to check these resources out. These resources are in chat as well. And then once again, we tend to do these coffee chats, every week or so. We tend to try and create a topic that is kind of relevant to what the industry tends to be working on, discuss common pain points and what tools we have out there to address them. So that being said, thank you so much for your participation today. Feel free to follow us on LinkedIn. Feel free to sign up for the developer edition on Orkes Cloud to try these out. And yeah, happy building. We hope to see you next time and enjoy the rest of your Wednesday.